Hey everyone, welcome back to the Drone Money Podcast. You're here for episode number 4, where we're going to be talking about surveying workflows. It's a great topic we're going to be discussing today. We have an awesome guest with us today to talk all about his practice in doing surveying workflows and a lot about planimetrics. He's going to share some data sets with us, so I think that's going to be really cool. And as always, I'm joined with our co-host, Daniel Wyndham. What's up, Daniel? How you doing today?
Hey guys, I'm doing great. How are you?
Well, man, I'm good. I'm on the road. This is a road show for me today in a Starbucks / gas station parking lot.
Well, that's very fitting, as all of us drone people know what that's like.
Yep. If you're not traveling and flying, then are you even working?
At least you're not at a gas station. You're in a much.
I'm in Starbucks next to the gas station.
You're in the Starbucks next to the gas station. You're
absolutely.
High class.
Yeah, high class. Now, before we get into the surveying workflows that you guys are all here to hear about, today I want to introduce a new product coming out from ROCK Robotic. It is the ROCK Base Core Station. So you're going to hear a lot about this thing over the next coming weeks and months. Basically, we're trying to build a distributed correction network, a GPS network. This is the ROCK Base. I'm holding it. And customers can purchase these for $750 and install them. And we're building a community-generated GPS correction network. So it does have a crypto network on the back end. So you're actually earning these tokens. And then customers that want to purchase the correction service, which is ROCK, will be purchasing it, or going to be spending tokens. So there's a little economy going on here. So you can earn by providing this on your rooftop. But this right here I'm holding is this ROCK base station. It's a triple band, 1,408 channel GNSS receiver in here. And for anyone who's interested, it is actually, if you compare it to a Trimble R12, which is the top of the top line for Trimble base station, RTK receiver, this is actually doing a lot better than that. That only has 672 channels, I think. This has 1,408 triple band, freaking sweet. But more about that. This is a little sneak peek. We're just releasing this, so there's going to be some videos coming out over the next coming weeks. I just wanted to get on here first and share with that. You get a nice antenna, goes on your rooftop. It's static, always stays there. And then we're building out a network of these around the globe. So that way you can get RTK corrections, and then also you're going to be able to get PPK corrections as well, all from these miners. And they're only $750, so very inexpensive. And we're doing that because we want to build this network. We really want to use this network. We want to leverage the data. And we think that you guys participating in it will be really exciting. So more about that, more of the ROCK Base. That is the one announcement I wanted to do this week before we get into some surveying workflows. Daniel.
Awesome. That's super exciting.
It's pretty cool, right? I don't think anyone else is trying to do this. So
no, I think they go, I don't know. But, I think it's super awesome for us, especially when you look out in the next 10 years, right? There's so many different items that are connected, and the accuracy of which needs to go from meters to centimeters or less.
Yeah, totally. Also, if you have to go in between states or you're traveling, because there are CORS networks today, but usually it's centralized to a state or a DOT, and if you're going to a different country, it's not going to work. And then maybe you subscribe to one like the Trimble network, or Hemisphere has one. It's going to be really expensive, and oftentimes the density of nodes really isn't there. Even if you're just a local surveying group and you just want to buy 4 of these, install them around your city, and just use your local network, well, this way you can participate, and anyone else who installs one, you benefit from that as well. So it's really like we're trying to get a community-generated CORS network going here and finding a way to reward people. So, like, how do you, like solar, right? You put solar on your roof, you sell back into the grid, some way you can earn back into that. So that's the idea, and we're doing it.
And how awesome is it that you could, if you've got 5 offices, well, you now have got complete coverage across your entire area that you made yourself.
Yeah.
And then if other people use it, then they're paying you.
And it's triple band. I mean, it's triple band. Exactly. And I mean, so the number of channels, it's usually with the RTK fix, it's going to be, with satellites coming into view, out of view, it's going to lock into all the satellites super fast. I mean, I've been doing some comparisons, running MLIDs in RTK versus using this and an MLID off of it. And like the RTK fix actually is incredibly fast whenever you connect into these stations as compared to like an MLID. So
and at scale, I get excited about it, but at scale, if you're not having to take a base station with you, if you just have a ROCK base at your office and you're in that area, if you have 50 crews, that's 50 fewer units you need. You can just get a ROCK base instead.
We will eradicate base stations. No, I think
base stations.
Yeah, we all good. So the other cool thing about the network is actually it runs on this like proof of accuracy. So each base station that you install or someone else installs, we're constantly checking the accuracy, basically running Opus solutions between everything, looking at a little network adjustment to verify the quality of the data from every node. So the nodes are constantly checking, always, making sure the data is good. That way, when you're logged into the network, you're guaranteed to have a solid connection and good network. So
That's awesome.
Rock base.
I thought about that the other day because when speaking about survey workflows, I was doing some testing with R2A, and I was flying an industrial park near my house. And guess what is all around the industrial park?
What's that?
Transmission lines.
Oh yeah.
So
that's going to interfere.
It was really hard to find somewhere that had a good signal, open sky, and I wasn't going to get killed. Yeah. So specifically, the last one is very important to me. But if I didn't have to worry about that, from a safety perspective, it's one less thing I have to do in the field.
Well, totally, and the quality of the signal too. Like you're good up to about now with so many different satellites in the sky, and you're getting like 28 satellites, and you're getting triple band. I mean, you can be like 60 kilometers away and still get a solid solution. I mean, especially some of the more fancy things when you have a bunch of base stations, you can actually extend that distance and do like a virtual reference station network. And these are all the things that we're going to be building on top of this network: the VRS, the RTK, the PPK. So that way you don't even worry about it. You just come back to the office and you sync that Rhinex file right with your post-processing workflow. Just having that ease of use and that security of mind is going to be, I think it's going to be really cool. Yeah, I'm really excited about this. If you can't tell, I will be talking about this. We'll have an Indiana Drones video coming out later this week. So there'll be a lot more information. But this group right here, you're actually hearing about it first. So we haven't talked about this anywhere else. This is the first time we're
just me and Harrison talking for 2 hours, sweet nothings about base stations to each other.
Well, I think I announced it to the rest of the ROCK company only last Friday. I've been working on this with like a small team, and we're really getting it going, really like making sure everything's fine. And then I was like, all right, time for the rest of the team to hear about it. And so kind of they heard about Friday, and now it's Tuesday. And now the rest of the world's hearing about it. So I'm pretty excited.
Surveyors lead the way.
Surveyors lead the way. Honestly, accuracy, precision, and finding new ways to do things better and faster is really everything we're always about. So that's what we're talking about today: surveying workflows. So Daniel, you've done a few of these, right?
Yeah. I know somebody else who has too. He's our guest today.
Yeah. Should we just bring Davey on?
Let's just do it.
I think we should.
We told Davey he'd have 15 minutes. We gave him 9.
That was 9 of us joshing around. Welcome everyone, and welcome Davy Johnson to the video today. Davy is an expert and a heavy user of LiDAR, doing a lot of different planimetrics. He's been doing SLAM. He's been doing aerial LiDAR. I mean, the list kind of goes on. I think probably it's best to hear from Davy himself about what he does and how he got into this industry. Davy, welcome to the video today. How you doing?
Hey guys, thanks for bringing me on.
Absolutely. Do you want to share with us a little bit about your background and who you work for and how you got into it?
Okay. So I work for my family survey company. We've got about 25 employees. We're down in the middle of Florida, a little bit north of Tampa.
Awesome.
I've been working here full time for about 15 years. I spent about almost 10 years in the field, working my way up to be a crew chief. And then last 5 years, I've been in the office as project manager and a CAD technician and doing estimates. I do various other tasks within the business.
You just run around the office all day until you get to go home, right?
Yeah, well, yeah. So
fire drill all day long coming to you.
Well, I didn't realize that, Davey. This is a family business, and even in the family business, they made you work in the field for a solid, a decade before they let you come in.
Yeah, I always after being here for a number of years, I recommend that every draftsman spend some time in the field. To understand what needs to go on the computer. It's kind of difficult to understand how to translate field to office without physically doing it yourself. So
I can absolutely imagine that. So maybe tell us a little bit more about that. It's like being out in the field, actually understanding how the data is captured and understanding kind of the limitations of, the practicality of actually, getting out there in the field, getting data, so that way you can understand how to draft it.
Yeah. Yep. So, I spent years, doing one point at a time, and we still do quite a bit of one point at a time for certain types of projects. And there's certain aspects of surveying that require field measurements on a number of different types of projects. But so
totally.
a little over a year ago, I actually, so every year I do this thing with my kids. It's a bring your dad to work day, or it's a career day at school.
Cool.
And so I've been doing this for a number of years, and in the past I would bring my total station, and set it up on a tripod, and the kids like to see it move robotically, and I would steer it around and make it shine the laser at the wall and stuff like that. Kids liked it. It was okay. So this last year I went to, a year and a half ago, I was getting prepped for another career day at school, in my kids' middle school. And I was like, you know what? My slides are getting kind of old. I'm going to look at, see if I can get some updated photos for my slides. And then part of those photos, I wanted to surveying look cool and futuristic. So I was like, let me look up some drone stuff. So I looked up some drone images, and lo and behold, I found a drone image, or maybe it was just a YouTube video from ROCK Robotics.
Awesome.
And that's how I found you guys.
Yes.
So I was literally just looking for some cool pictures to put on my slides. And I was like, you know what? We had looked at drone surveying tools before in the past. And in the past, it was way out of our price range. We weren't really seriously considering it.
Were you looking at like photogrammetry at all too? Like just like Phantom 4 or this kind of stuff? Or
no,
what were you kind of looking at?
No. We were never particularly interested in photogrammetry. We have subbed out for large surveys in the past. There's a company in Central Florida called Pickett, and they have airplanes, and they do large scale LiDAR. We had subbed them out for a number of jobs in the past, for when we got a job that was so huge and had so much elevation change that we just needed a LiDAR scan for it. So we were familiar with LiDAR data a little bit, but we didn't do any of the processing whatsoever. They would just give us a final deliverable product that was basically a tin surface that was on anywhere from like a 1 foot to a 3 foot grid. And we knew that when we were given those surfaces like that, it would crash our computers. We would dump all of that into AutoCAD and try to produce a survey out of it the same way that we always do with our typical surveys. And we'd realize that, wow, this is way too much data. So we'd be emailing back and forth and going, hey guys, can you really help us out here? This data is kind of unusable to us. We can't process this, 2,000 acres at a 1 foot grid in Civil 3D. It's not going to happen. Yeah. So anyway, we're familiar with LiDAR data a little bit. Never really got interested in photogrammetry because we just hadn't considered it, and I don't know why. And I still haven't done much photogrammetry. I know a lot of the people in the drone industry are really into photogrammetry, and I don't know. I don't really know much about the photogrammetry aspect of it.
Well, you jumped right into LiDAR, so you just kind of went right over there.
Yeah, we were right into LiDAR.
Yeah.
And then since then, I've reverse engineered. I've gone backwards, and I bought a P1 to go on my
awesome
DJI M300, and I've been making some aerial maps, but I have not been able to get the accuracy.
Honestly, for me, going from like the photogrammetry into to LiDAR. So I mean, when I first got going, I was doing a lot of photogrammetry missions before I got into LiDAR. And kind of one thing that always, whenever I got the opportunity to do a LiDAR job versus photogrammetry, I really enjoyed the fact that sometimes when you do photogrammetry, you don't get stitched photos. Like you get like you'll miss some area, or like some in Pix4D you get red dots when the photos aren't finding those key pairs. But like with LiDAR, like if you got, the base station's recording data and you're recording data on the LiDAR, like it's going to produce an LAS, and like it's that direct georeference. To me, that was always like,
yeah.
When it came to peace of mind, even if I was trying to deliver the same thing I was doing with photogrammetry, I would still like to use LiDAR because I knew it would work every time, as opposed to like, maybe I got to go back out and shoot a few more photos and hopefully it stitches together. Much better today, but
the photogrammetry still seems like a little bit of a black box to me. Like when those programs stitch those pictures together into a model, I don't actually know what those programs are doing in the background. It's kind of a mystery, and I know that they can be contorted and moved. And I know that also sometimes when I overlay my orthomosaic onto my survey, it's still not quite right. Like you can line up 3 or 4 of your targets here, and then you realize that some of your targets aren't lining up over here. And there might be better ways to do that. I'm not great at it, and I know that
totally
there's more that I need to learn about GCPs and for photogrammetry anyway.
Well, one cool thing, Davey, that you bring up, when we're talking about these workflows is trust, right? If you don't understand something, you don't really know what's going on. Like, can you trust it, to be in your surveying workflow? And the cool thing about using drones, whether you're talking about photogrammetry or LiDAR in here, is once you build out that progression that you can do every time, you can scale that up, just like you do. And, maybe you can talk a little bit about how that's worked in your company to where you went from basically not flying anything and subbing it all out, and then kind of adding this drone crew, over here that's doing all this work. I mean, what was that process like? How did it affect your business? What kind of financial impact, as much as you can talk about it, is going from not flying to flying as much as you can?
Okay. So like I mentioned before, we had subbed out some LiDAR work in the past, and then we were getting more and more jobs. We eventually started subbing out another company that had drone-based LiDAR, Bowman Consulting, good guys. And we were paying them lots of money. We were doing LiDAR, or subbing them out for LiDAR surveys. And I met with them on the job, and I was fascinated by drones. Of course, guys like us, we love toys.
Right? Yeah, totally.
Honestly, we have several of those guys probably watching.
Right? Yeah. We're flying robots in the sky, shooting lasers from them.
Right. And so the idea that I could do that and also do the same in the same industry that I'm already in and make lots of money at it, I'm like, yes, this is a triple win situation.
That's the bumper sticker right there, Davey. I'm going to do something awesome and make more money.
Yeah. So, and I get to get out of the office now because I don't really particularly like the office. So now I get to go out in the field a couple days a week. I like Daniel's idea of Friday Fly Day.
Yeah. I started that to keep myself sane.
Yeah. Except last Friday.
So you guys really got into integrating drones into your kind of workforce just in the past, 12 to 24 months. And although the company's been around for, what you said, 25 years?
Yeah,
30 years.
Going on 35,
Wow.
Going on 35 years. And just in the past 2 years, you're getting into a whole new workflow. And so, how is just in general, how has that affected the company or like productivity or even skill sets, I guess you're looking for? Like, what are the negatives too? Like, 'cause obviously it's a hire new skill sets to fly drones, but there's positives as well. So kind of talk about that in the context of, running a, survey company for so many years. And now all of a sudden this new technology comes out. I mean, you guys are probably around robotic total stations were kind of really coming popular.
Or GPS.
GPS, right?
The old guys here, my dad and some of the other older, the more seasoned surveyors here. They've got lots of stories about all the, my dad bought one of the first electronic distometers back in the 70s. Well, the first survey grade one. I'm sure there were other ones out there, but the first one that became affordable and popular for surveys, back in the 70s or whatever. And he was like, man, it was such a huge leap in technology to shoot a laser distance and get it back, instantly instead of having to
totally.
It's a lot better than walking, isn't it, David?
Oh, I know. And so now when we explain, so then we've gone through several seasons of integrating new technology. over the last few decades, of course. And when GPS got introduced to the surveying field, we were kind of an early adopter of GPS technology also. So yeah, there was a lot of, in the survey industry, there's a lot of skepticism about new technology, especially with GPS. And we've encountered, skepticism towards drones. And I actually had to spend some time learning from you guys, and then convincing the surveyors here that, hey, if I fly a survey with this drone, it's gonna, if I fly LiDAR, it's gonna produce the accuracy that's similar to the GPS accuracies we've been getting all along, and I've got to convince them to sign these surveys. So
right. Now how is that going? Are they feeling comfortable with it now, or?
Absolutely. So it is a what do you call it? At this point, we've been doing it for just over a year. At this point, it's an indispensable tool. We're never going back. There's no way.
Yeah. Why would you?
Right. So,
Davey, could you do as much work as you're doing right now if you didn't have drones?
No. So that was another thing. The industry in Florida the past few years has just exploded. There's construction like crazy. I don't know if it's this way around the whole country, but I know in our area in Central Florida, it's just blowing up. The economy's starting to slow down, but Florida has not slowed down. We're still cruising.
So I guess that's the challenge of finding employees. Even if you were to do it, your previous method, you have to find a number of employees, field crew to go out there, and so now with the drone, presumably you're doing it much faster, and so less employees you need.
Yep, and we haven't. That's the thing. Yeah, we haven't gotten rid of it.
No, we're growing.
It hasn't taken anybody's jobs. We've just gotten that much more work, with it.
Awesome.
With the technology.
Well, that's enough for today. We're just going to make more money. The workflow is do it. But David, can you talk a little bit about we're kind of breaking things down in what's it like when you get the call or you get the email with the parcel ID, and it's like, how do you work that into your business where you're incorporating drone mapping? You get the call, and then what happens?
Okay, so we still do. I work with my dad. My dad's still up here. He does estimating as well. And he'll call me into his office, and he'll say, hey, we just got the request for this job. We got 100 acres to fly. It's got a little bit or to survey. First, nobody cares whether we fly it or not. They just want a survey.
Yeah, exactly. They don't care. Just do it.
Right. They want a survey. So they need a survey done. So first thing we always do is we actually pencil down how much it would cost us to do traditionally. And so we write that on one sheet of paper, and then we pull out another sheet of paper and write down all the estimated costs for what's going to take to send me down, fly the job, come back, process the data, pay you guys to help us process the data, and then draw planimetrics if it's one of those jobs. So we factor that into our quote, and then every time we sit back and look at the quotes, like, well, that's a no-brainer. Looks like we're going to fly this one. And
So what type of jobs? Yeah, can you describe the types of jobs a little bit for anyone who's listening and doesn't know everything about when someone calls in with a parcel, like what are they actually looking for, and like what kind of scope of the work would be?
Right. So obviously the big topography jobs, where you're looking at anything more than like 20 or 30 acres, you got to fly it. Sometimes it's still cheap enough to send a crew out, because by the time you set ground control and send a crew out to do all that, there are certain situations where the crew can handle it.
Yeah, you got a 2-acre gas station or something like that.
Yeah. Right. But so obviously any type of job where there's a large plot of land that's topography, we're going to do that. Where we initially bought the drone and the ROCK Robotics, the full package, we got an R2A and we got your software, the ROCK Cloud. We did not realize how much we were going to be able to leverage the planimetrics. That was kind of like an added bonus. We were just like, initially we bought it with the intention of helping us get big topography surveys done. But since since we've integrated it into our workflow so much, we've been doing route surveys. We've been doing a lot of route surveys. That's one thing that we've been kind of pushing, pushing on the technology to do for us, where you can fly a route, and sometimes you guys gave me the R360. We bought the R360 from you also, and it's got a truck mounted setup.
Mm-hmm.
And I've done a handful of them with the LiDAR mounted to the truck, depending on the situation. But I tend to like the aerial surveys better. They get more data. There's. Is that my project there?
Yeah. If you want to talk.
Yeah, let's talk about this. So let's talk about actually. So you talk about planimetrics and leveraging planimetrics a little bit. Why don't we let's talk about, maybe Daniel, do you want to describe to the viewer what is planimetrics? What are we talking about? And then maybe more in general terms, and then we can show examples.
The idea of planimetrics, of course, the way that we talk about it is actually kind of an enhanced way. Planimetrics usually means plane, right? It's the line work you can get even from imagery, but when you're extracting it from LiDAR, you're able to gather features, man-made features normally, from the Earth with the drone data instead of with the field crew. So, for example, here on Davey's project, you see we go from, we have...
Look at that. That looks so cool. Sorry.
It's awesome. We got tree-lined buildings, parking, and, what's cool about that is, look at that. That's awesome. But then let's go over here and look at it in AutoCAD. Like, it's here.
Yeah, it's awesome.
This checks out. We've got manholes, turn arrows. All of that is labor. That's just labor we don't have to do, right, Davey? You can kind of go more into this, but.
Oh yeah.
So what was the scope of a project that requires planimetrics? Like who needs this, and why do they need it, and what's it being used for?
So that job in particular, we didn't need to do topography at all. That was basically an Alta survey. And those are that's a big government housing complex down in Tampa. And they're, for whatever reason, they've hired us to do various phases of their big complex there. So that's just phase 3. We had previously done 2 phases of the same project before we ever had the drone LiDAR. And I actually wrote some numbers down here while you guys were getting ready.
Yeah.
So in phase 1 of that project, we did a few years ago before we had a drone. Phase 1, we contracted for $83,000. It cost us $66,000 to get it done. So we ended up profiting $17,000 on that, which is like a 20% margin.
And that's good. That's good margin.
But that's previously. Yeah, so we did good on the job. We were happy with our profits on that job. But that was about 4 years ago. So this one we just did earlier this year, or late last year. That one was a smaller portion, and so that one we contracted $44,000. It cost us around 10.
Wow! Wow!
Yeah,
that is awesome.
So.
Wait, if I'm doing my math correctly, that's you made more money doing less work.
That's right. We made twice as much money on half as big of a job.
Yeah. Wow. Wow, Davey.
That's a 77% profit margin that we made on that one.
Not too shabby, if I say so myself.
Yeah, not too bad.
But you probably did it also quicker too. So yeah, let's talk about the workflow of like how this was produced. So actually, Daniel, do you want to bring that screen back up?
Yeah.
And so I want to kind of go backwards a little bit. Those numbers are freaking amazing, by the way. But just for the viewers listening, these planimetrics, this line work, this is being used to kind of model the existing infrastructure, right? And so if you're going to build anything into here, I always come back to I'm building a new Walmart or gas station, but there's already a sidewalk. Well, my sidewalks need to match the existing sidewalks when I build this new one, or anything you're adding into the world has to always line up with the things in the world. And so all of this data is being captured and brought into, an Alta survey, whether it's for tax purposes or design purposes. All this data is important because you need to have accurate information in your CAD software so that way you can design and build anything new, that integrates in with the existing world. I think to me, it's always like, how do we, you think about the world as this hodgepodge of all these construction projects going on, and heck, we all have to use the same sewer system. We got common roads, we have, sidewalks, the power system. It all needs to like integrate together. And so getting this type of data and getting this vector work into the CAD software is what's going to help us, do all that integration. So just for a high level kind of, I'm sure there's so much more to it that I missed, but that's kind of high level what needs to be done. But let's talk about this in particular. So it looks like you flew this, and then so what all went into this project to getting what we're seeing, and what else you had to do after what we're seeing to actually get the project done.
Okay. Yeah. So this project initially actually is when I first bought the R360 from you guys, and that was my first SLAM project. Well, my first large SLAM project. I did a few testing projects first, but this is my first large SLAM project, and that's not 100% SLAM data. That's actually all merged together. Mm-hmm. I merged my SLAM data with my aerial LiDAR data as well. So I think there's 3 different SLAM data sets mixed in there as well. And then I can't tell by which one you're looking at.
Just SLAM. This is just SLAM right here.
Okay.
So that's the SLAM data set. So how did you do the SLAM? Did you walk around? Did you put it on a car? You just did walking.
I built myself a backpack. I know you guys have seen it.
I saw it.
Yeah, I should have brought it with me. I don't have it with me right now, but I built myself a backpack, and I have like I wear it, and the light sits right above my head, and I have it set up to where it can face forwards or backwards, and I was just experimenting with it. Man, the people, that's a housing complex where people live. And I was walking around surveying that thing. Everybody was looking at me like I was an alien, because I'm walking around.
Yeah.
Actually, they started calling me the professor. That was my nickname.
Really?
They nicknamed me the professor. Yeah.
The nutty professor walking around the streets with his laser backpack.
I mean, that was crazy. Like, you had a laser backpack walking around somebody's neighborhood. Like, imagine everyone at home looking out your window, and this guy's just walking around 1.2 million shots a second.
I have no idea. Yeah, I have no idea. So it's really cool. So you walked this with the SLAM. So you're using the R360 ROCK SLAM, and then you come back the next day or whatever, and you fly it same day.
Yeah, same day. I unhooked it from my backpack, hooked it onto the drone, and took off. And
pull that data set up, Daniel. I want to see the aerial.
This is the aerial.
Yeah, SLAM. Yeah, the downside to the SLAM data is it's not colorized.
Yeah,
soon. Soon.
Don't tease me. Because the colorized data is quite nice to have.
Oh yeah.
I like the swimming pool. You can tell where the pool is.
Yep.
Nice.
So now you're doing the SLAM data because you wanted to get that ground perspective and see the sides of the buildings, the curbs better. What was the rationale? Why didn't you just do aerial?
There's a lot of sidewalks, and the sidewalks lead up to the front porches on the homes. And in this particular job, the client was particularly interested in making sure verifying where all the sidewalks are. So
got it.
There's a lot of overgrowth, and some of the limitations of the planimetrics are when you fly it. Sometimes if there's sidewalks underneath trees, it's difficult to see the precise location of those sidewalks, especially if they're winding around and going all crazy. So I knew that I was going to have to integrate some SLAM data as well as aerial data to get those sidewalks in there and the steps that lead up to the buildings. So that's why I did that on that particular project. And
Davey, I'm mesmerized right now. I'm sorry. I'm looking at Daniel sharing his screen, and I'm trying to listen to you and look at everything at the same time.
Yeah. It's a lot.
It's mesmerizing.
Yeah. So ROCK Planimetrics in this particular job did I want to say 95% of the work here.
Okay.
There's still a small percentage that, after we get this back, you're going to see some areas in that data set where some of the sidewalks are just indistinguishable. And that's just a function
and they're
of,
indistinguishable in real life, right? I mean, that's just real life.
that's true. Yes. And that means, also you have to oftentimes kick the leaves and the grass off the edge of the sidewalk to see where the corner of it is.
Like right there. It probably goes to the building, right? You just have to walk around it
Right.
and go, yeah, okay, so I'll extend it and then I'll just do this. Done.
Yeah, we can do something like that. But usually when there's stuff like that, we'll go do a handful of field checks as well. So
Yeah,
totally.
We'll print the planimetrics and send the crew back out with, some red circled areas and say, okay, we need some clarity on this area, need some clarity on this. Another limitation of LiDAR is all these manholes that you have here. We don't know what kind they are. We don't know if it's a storm or sanitary. So, the crew has to go back out and mark whether it's a storm or sanitary or whatever it is. And also certain utilities, like if there's ground level utilities, like if there's a vault, that's at ground level right next to the sidewalk that has the Verizon box or whatever down there. A lot of times the planimetrics isn't going to be able to distinguish that because
totally
you have to have boots on the ground for certain things.
Yeah. But if you're getting 95% of your workflow taken by somebody you don't have to pay, who doesn't need insurance, who doesn't call in sick, I like it. I like it.
Yeah, no, totally. I think that's actually, it's really awesome. I'm still just mesmerized by the integration of everything. So you did the SLAM, you did the aerial, and I assume you merged it all in the ROCK Cloud.
Yes.
And then once you merged that, you just ordered planimetrics, and then you kind of went through here and said, oh, here's some areas that, and you can kind of see too, I'm sure, in the visualizer, like, oh, this sidewalk, I can't even see it here in the data. So then you highlight some areas, a field crew goes out, gets a few, check shots, some data, and then you bring it back in, should do what Daniel was showing, kind of just update in Civil 3D. And then that's the end. That's the whole project.
One thing I love about that data set is how well you can see the walls on the buildings. A lot of times when you fly LiDAR, you see the roof really clearly, but you don't necessarily see the walls. But yeah, when we integrate it all together,
that's awesome.
You got 4 walls. You got the corners really clearly.
Yep. You can measure, take a look at it. See, you could even see it's almost 90. They got it close. I'm just kidding.
Yeah.
I mean, I think showing this to any surveying firm, though, just being like, hey guys, this is what you can do. Like, you got Backpack Man and flying the drone, and then boom, look at this. Yeah. I'm just kind of talking to the audience a little bit broader speaking, because I know some people are just interested. How do I get into this? How do I start? And you had presumably an awesome childhood, getting into this line of work with your family. I'm pretty jealous. That's awesome. I mean, my family, we do LiDARs and drone and software. So, but we're big outdoors guys too. So like being able to get out there, do the field work, understand what goes into this work. And so for you, seeing this data and coming from, 15 years being out, 10 years being out in the field, 35-year-old business going from chains to, GPS to robotics to now drones, and seeing the evolution of a workflow and being able to now go out in one day, capture all this data, click a button, you get 95% of the planimetrics done for you. And then now you just send out a 2-person crew and you're making more money.
Yeah, no doubt.
I think that's the underscore to the whole thing.
Right.
Mm-hmm.
Yeah. That's
those are some good drone money numbers.
Well, Davey, hats off to you.
Well, and Davey, can you speak to is that typical, or is that like one you want to go jump up and down, or are you seeing returns like this normally, or at least in the same ballpark?
That's not surprising. No, these numbers are not surprising. And the bigger the job, the more profitable it becomes to use the drone. Because, again, the economy of scale. You can do a small job in a short amount of time with a survey crew, but the bigger the job gets, the more money is there to be made with the drone.
Let's talk about a little bit about the future, Davey. So, I mean, obviously your backpack's awesome. I love it. But right now it's kind of like you're getting this technology and you're integrating into the family business there. And what do you see the next 10 years looking like for you guys? Like how does all this play out? What do you think?
Okay. We're definitely going to be using the drone LiDAR on more and more surveys as we go about it. I know Daniel has been discussing, trying to get a drone on every survey crew.
Yeah,
we haven't quite gotten there yet. Currently, I'm the only pilot here. We've got one other guy that's got his Part 107 that I've been having him do some photogrammetry jobs just with my little toy drone, just to kind of supplement our surveys. But we don't use those for survey data really because, again, I don't really trust photogrammetry, or I don't trust my photogrammetry as well. But anyway,
I'll help you out.
What's that?
I'll help you out.
Yeah. We will be definitely at some point breaking out into a second drone operator, and we might be doing more in the future as well. One of the things that it was a bit of a learning curve and took some getting used to was taking a LiDAR data set. And you guys actually worked with me a lot on this, and I was really impressed with the customer service that you guys gave us. Because initially when we first jumped into it, it was pretty cumbersome getting from a LiDAR data set into a usable file that I could put into Civil 3D and use it and give it to our engineers, our clients, in a format that they could use. So anyway, yeah, you guys were extremely helpful towards the beginning in getting me the formats that I need to turn over to the engineers, and I've been really happy with that.
So how are they liking the data from the drone now? Like, do they even know? Are they even,
They know, yeah. That you can tell.
Oh, they know.
Yeah, yeah. So, I haven't gotten a ton of feedback. Again, they're more interested in. They just need their survey. That whether or not it came from a LiDAR drone or from boots on the ground. I don't know if they really.
No feedback's good feedback.
That's what the thing is. What I'm hearing is you haven't had complaints.
I know. No, we haven't had complaints. The only there have been a couple, like, I don't want to say complaints, but we've worked with a couple of our clients on, again, reducing the files.
Yeah.
Because sometimes I'll give them the entire DEM, which is a 6-inch grid.
It's a little too much.
Yeah.
Right. Yeah. So they can't handle that. So I'll help them reduce it down. I'll reduce it down to something they can use. And then we have different clients. Some clients actually just want the contours. But
totally.
Majority of them actually want a tin surface, which is what we're used to working with in Civil 3D is a tin surface.
Yep.
So yeah, getting to a manageable tin surface that accurately reflects the ground, because there are wrong ways to do it.
Yep.
You can use LiDAR data improperly and build a tin surface that doesn't accurately represent the ground if you're not careful. So getting to a place where we can trust our tin surfaces as well as, it really, that's not a matter of trusting the LiDAR data. It's just a matter of a proper application of the LiDAR data, because the LiDAR data is tight. Yeah. I can't think of any instances where I've mistrusted the data coming back from the LiDAR. But just getting from the raw data set to a final deliverable project, a product for us, there does still require a lot of thought and planning to make sure that you're properly applying the LiDAR data.
Totally.
To get that service.
Totally. I think that's something that, like, we, at ROCK, what we do all the time is, like, we just like working with people to figure out, because everyone has different needs and requirements. And just recently I got into I'm active on the old Facebook, and sometimes people will comment, and I'll get into a little comment war. I shouldn't, I do, but it happens.
Someone you can bottle up, Harrison.
Well, someone was really complaining about the contours. It's interesting because a lot of customers say, hey, we want it this way, and some we want it this way, and there's just this big, disparity depending on what you're doing of what exactly you need. And so, but that kind of those conversations resulted in us releasing this smooth, medium, and rough contours. So now customers can just choose what they want and download whatever they need. And I think like these conversations right now, having with you and having with other people, the feedback, when you mentioned the support from us, and I think it's imperative to us because the conversation always gets the ideas flowing, and we build something that doesn't work for someone, then why even building it? So
So what I've been doing with your data, I really only have been using the contours mostly for reference, me personally. Usually what I actually use is the super dense DEM surface primarily. And I'll use that to then generate points that my field crew would have shot.
Building a grid.
Ways of creating those points. Another thing that you guys did in one of your software updates was allow me to export a grid and set the size of the grid. So when I'm processing like a roadway, I'll use the super dense surface because I need to know if the curve is up here and the edge of pavement's down here. I need to be able to catch that. I can't just blaze right over that with
exactly.
And you order brake lines a lot, Davey, right? So that we can capture that whether there's a point there or not, the brake line's going to catch it.
The brake lines will catch it, yeah. So, yes.
So if you guys are watching this right now, you're hearing it first from Davey. He asked us to build something, and we're basically his personal dev team. And
don't tell me that.
I'm joking.
Before I was working with Rock, right? I mean, I said, hey, can you do this? And then the next day they were like, yes, it has already been done. And I was like, whoa, what is this black magic?
Yeah. I always start off my conversations with Dan saying Dan is the man because he gets it done.
Davey, tell me more about your experience with the Slam. So obviously, we kind of soft release Slam, and then you jumped on, and then we've been, quickly iterating on Slam as well. And it looks like now you're using it in practice in the field. That's awesome. It's really awesome.
Yeah. Now again, this was the biggest project I did. This one that you guys pulled up. I've got a couple other smaller ones. Most of our jobs don't require the level of detail. So most of our jobs I'm going to fly. It's only certain situations where I'm going to use the Slam. Our company doesn't do a lot of detail work around buildings. So
or like looking at actual pipes and these things. Yeah.
Right. Yeah. So I know that a lot of your Slam data sets, you like walked around the inside of a school, or it was right. And I actually did a portion of the community college near me with that because there was a fly bridge and they needed detail on the bridge. How there was an overhead walkway.
Yep.
So I walked around that thing in about 10 minutes and had an immense amount of data and every measurement I could ever want. Whereas a job like that, trying to have the crew shoot points, one point at a time, and trying to define that building and how that bridge was set up and the sidewalk underneath it and all the topography associated with it as well. It would have taken a day and a half. And it was literally a 10-minute like a walk.
Leisurely stroll.
Right. Yeah.
That's great. Hey, Davey, I mean, this has been a fascinating conversation, and I know everyone has been, really getting a lot of information here, and I'm really thankful for you coming on. I think it's awesome. We're going to put up a photo of this backpack that you created here in a second. Yeah. There it is. There's the backpack.
Yeah.
This thing is, when I saw this, I was like, genius, this man.
Yeah. I did have to butcher the box to do that. I've since added battery packs. You guys recommended some batteries, so they just click right in to the sides.
You got battery holsters.
Yeah.
That's awesome. I'll
send you more pictures because it's pretty cool.
Yeah, let's see more. Well, let's open it up for the audience, and let's take some Q&A session and get some questions answered. What do you guys think?
Yeah, let's do it.
I'm ready.
We have some questions.
Question time. All right, we got our first question coming in. Being a drone service provider, still quite new to the game, is it possible to do mapping for surveying? I'm not a licensed surveyor, solely as a service or as a DSP, a drone service provider, DSP. So we get this question a lot about the legalities of providing the data. Now, I think, I'm going to jump in and answer one thing is you can't provide a survey. Like you definitely cannot do that. There's,
Right.
An actual process of delivering a survey. And in a lot of places, you can provide data as a service provider to a surveyor, and they can then use it for their needs to do, surveying. So, David, do you want to talk about that a little bit, or what do you think?
Yeah. So some of the subcontractors, when we hired out our drone or our LiDAR data before we owned it, they did happen to be licensed surveyors, but they didn't provide for us a survey, as you said. They just provided for us data. So we're the surveyors. We take that data. We decide whether or not it's accurate enough for us. We do our own ground truthing. We make sure that data is something that we're willing to put our signature on.
Exactly.
So then, it becomes a survey. It's not even really a survey unless it has a seal of a surveyor on it. So we actually take data from all kinds of sources and create a survey. So even our field guys, that's
what I was saying. Your field guys, like your techs, they're not all surveyors.
Right. Yeah. They work under the surveyor. Only the surveyor can sign surveys. And if the surveyor is willing to trust the data that they're getting from you, I don't want to speak to the legality of it because I know, like in California, there's different rules than Florida.
Guys, in California, it's literally states. So, I talked to the survey board, and because they were pretty mad at one of the videos I made. But I was not doing a survey for one thing. It was just a YouTube video. Just to be clear here, everyone, it was just a YouTube video. But technically, so they quoted like the actual language. Any like GPS or like using data to find a location is considered a survey. So by that logic, Google Maps is surveying because I'm using a location service to find a location.
This is a survey,
right?
But I think it's just they're getting used to how this works, and there's no bad guy here. It's not.
Yeah.
And I think I want to make that clear. Is like the surveyors are actually the kind of the heroes that built our country. Thomas Jefferson was a surveyor, guys.
George Washington.
Yeah, these are
three of the four guys on Mount Rushmore.
Yes,
surveyors.
Pretty good.
Exactly.
And it's not a shock for government regulation to be out of date, right? So that doesn't mean anybody's the boogeyman. But
I think at the end of the day, there's just like a gray area, and people are really, really confused by this. So it is one of those things that you should. My personal advice is just to make relationships with surveyors.
Yes.
Make that bridge that connection with them. Show them what you do. Get that relationship and that trust with them. And then, if they're willing to use you, really it's like, that's where we're talking about here. I think it is a relationship thing. I don't think you're getting in trouble if you have that relationship and it's not strictly prohibited by your local area. So I don't know.
We always just stick to truth and labeling. We tell our clients exactly what we give them. They know where the data came from. They know how it was produced and how it was provided. If we hired a subcontractor, we'll list that in our survey notes.
Put in the notes,
and we're in the clear.
Awesome. All right, let's move on to the next question. Davey, do you use GCPs?
Yes, I do use GCPs. If you were listening at the beginning, I mentioned that I don't really use GCPs. I was talking about for photogrammetry. I don't know how to integrate GCPs into my photogrammetry very well. But yes,
very well.
Yeah.
I think very well. I think the key here is Davey's saying very well, because I know Davey knows how to click a couple buttons to tag a photo with a GCP. He knows how to do that. But it's like, where do you properly place them every time to get that best accuracy? I think that's the artwork of photogrammetry, is knowing like exactly where to put them, as opposed to like, oh, I know I need to have GCPs. Those are two different conversations.
Okay.
But the cool thing about LiDAR, right, is you don't need that many.
The way the LiDAR works, essentially every shot is a side shot. There's no so you line it up with, and I've very rarely seen my LiDAR data when I line it up to one or two GCPs and get it nice and balanced. Once I do that and then go to compare to my other ones, I'm rarely out of tolerance, where
Totally.
I'm happy with it. And what I've been doing a little bit more recently is, instead of just shooting the center of it, I'll shoot multiple points on a ground control or a target, and that way, because sometimes lining it up exactly on the middle can be a little tough, but if you can move it around and balance out 3 or 4 shots around the target, you can get a little more accurate that way. And then the other thing is, I really have to spend a lot of time coaching my crew on making sure my ground control points are flat. Not because they put those aerial targets and they'll just stick a nail in the middle of it, and then it bends down towards the middle of the nail where they stuck the nail through it. I'm like, that kind of works, but I prefer it. So
awesome.
I prefer asphalt targets. I prefer putting targets on the asphalt.
The answer is yes. He uses GCPs.
Yes. That was a long-winded answer to that question. Yes.
Davey, we got another one for you here. What drone or other equipment do you use?
The drone I use, the M300 that I bought through you guys, and then also the R2A is what I started with, and then a few months back I bought the R360 from you as well, from ROCK Robotic. So all ROCK Robotics, everything. And the MLID, you guys provided the MLID, which I use for my base station. Aside from that, our survey company we've been using TopCon survey equipment for probably the past 10 years or so. Here's one of my field controllers. I don't know if you guys recognize these.
This is
survey. And before that, we used Leica. When I first started working here, we used Leica equipment. We used Leica GPS, total stations, levels, all the typical survey equipment.
And pretty soon, David will be using a
ROCK
base course network. Anyway, sorry about that. That's awesome. So let's go to the next question. Curtis is off of the camera here. He is our guiding hand that helps us. I don't see any of his questions, so I'm reading them the first time with everyone else. Does Davey have regrets getting the R2A?
No, absolutely.
No, I say that
for him.
No, I still use the R2A. Actually, I have my R2A sitting right here. I still use this actually quite a bit. I find with the R2A, if I'm going to fly an area that has more dense trees, I can fly a little bit faster and get more data with the R2A. The R360 doesn't quite get as dense of data as the R2A. So, but the R360, when I'm flying a roadway or a route survey, or when I need to get curves and gutters or super tight roadways and stuff, I'll be using the 360 because the data is a little crispier coming back from the R360.
Definitely crispier, and that's for those people listening, like that's basically the R2A. The whole field of view is pointed down at the ground. So when you read the points per second spec that you see, on the specs for the product, all those points are going towards the ground. Whereas the 360, divide those points by 360 degrees. You're probably only using a 60-degree field of view, so that's like 1/5 of that data is actually going to the ground. So having that so many more points on the ground, it increases the likelihood of going through dense vegetation and hitting the bare earth ground. So that's cool that you actually find that. Because definitely in Florida, you guys have some dense veg down there.
Yeah. A lot of our surveys are we need to penetrate through trees, and that's what we do.
Awesome. All right, next question. Are the ROCK deliverables manually verified for accuracy before being given back, or all automated? They're all QCQA'd by humans. Yep, every single one of them, all of them. They all are going through.
Sometimes more than one human. I did 2 this morning, and I wasn't the first one.
We all kind of share the burden. We have a lot of experts here that we all just we look through every single one. And if customer has an issue with something, they'll write back, say, "Hey, WTF, what's going on here?" And then we'll jump on and make sure it's done right. I think that's the one thing that when I was kind of talking earlier about the contours, the smooth and rough, like that was something that came back from an actual project that someone got delivered, and so we turned it around and turned it into a feature for everyone. But yeah, we everything is manually QC QA'd.
What we got?
By humans. The job that Daniel is showing and telling that Davey did, can you share with us how much did it cost to process the captured data with the ROCK Cloud? Davey has the answer. I do not have the answer in front of me.
Yeah, I can maybe look that up, but it's so what is it? It's $20 per acre for planimetrics.
Yeah, I looked it up, Davey. If you don't care for me to say.
Oh yeah, no, go ahead.
I don't have it. It was about $1,800. So it's 94 tokens, and you did so. You made 34 in profit on that job.
Yep.
So you could just pay us a little bit more, right?
Yeah. So wait, hold on, Davey. I wrote it down. I mean, you charged $44K. Yeah. Wait, Daniel, how much did we?
I think it was $1,880. It was 94 tokens. $20.
And you said we did 95%.
Yeah. Harrison's making pricing changes right now, Davey. You've said
I'm actually on the website right now, Davey. Did I say $20 an acre? No.
That's for rural. Then urban, it gets more, right?
Yeah, I think so. Yeah,
well, we do have people that do entire interstate corridors. One of them being me back in the day. So yeah, I mean, pretty dense.
Yeah, what's the highest rate right now? It's 3 times that, or is it 2 times that?
It's around 50, I think, 55.
Yeah, exactly. So that's like the highest rate.
Yeah. That's still, I mean, that's not a lot.
This is a good question. How accurate is SLAM data in the instance of getting measurements for inverts or sewer manholes? This is a great question. I think
I haven't used data for, I imagined mounting my R360 to a device that I could stick down in a manhole and pull it back out. Yeah. I haven't done that yet. It's just living in my imagination. I don't think I'm going to do that, to be honest.
Yeah. Oh, drop it in there.
By the time, by the time I'm there opening a manhole, I might as well just get out my Philly rod back here and measure down.
Yeah, and there's a couple things with inverts too. One that Davey's talking about is liability. You want the invert to for sure be right? So you're probably going to shoot that and see what's going on. But also SLAM needs a little distance between what you're seeing and where the device is. And by their nature, they're small. I will say, though, I wanted to end on a positive note. I did stormwater culverts in my neighborhood with SLAM, just handheld, and they were perfect. I mean, they were 18-inch pipes. They were showing 17.9.
Yeah. As long as there's no sediment or buildup or water in the bottom of your culverts, I find the data to be very tight. The biggest hurdle is a lot of times there's stuff in the bottom of your invert, and you're not getting a true measurement of what's the bottom.
Yeah, that's why I'm usually telling people, like, no LiDAR is going to see through the Dairy Queen bag in the ditch right in front of the pipe, right? Like, you still have to kick that out of the way.
Right. That's good. I mean, I think you might know who asked that question, because I've been asked that question a few times, and I think every day we're testing new use cases as well. So I'm glad, Daniel, you went out.
I thought about doing it before I worked here too.
So, yeah, did you?
Yeah.
Awesome.
Yeah.
Awesome. Next question. The ROCK R2A data from Walk Slam should be okay if aimed properly, right? Or are we talking exclusive about the R360? So yes, the R2A data, it also works. It's just a little bit more tricky. Just so it's all technique. I think this is the one thing with Slam that's a little bit different is it takes a little bit of a technique to get it done right. So essentially what I'm saying is that, yep. So Daniel's holding one right here. Basically, oh, hey, I can see my reflection.
I was about to say, I can see you for a second.
That's a laser me. Basically, you want to keep that field of view that it's looking at some objects. So, like, don't go right up against a wall, like this wall right here and hold it so you're only seeing this blank wall. Then it's going to lose its positioning because it doesn't have key points, any features it's like looking from. So the good thing with the 360 is, like, even if you're walking against a wall, well, behind you, it's seeing everything else. So short answer is yes, you can use it. You're going to get, similar accuracy to what the R2A aerial will get. And then same thing with the R360, you're going to get the similar. So there's an actually difference, and that's based just on the sensor itself. So.
Mm-hmm.
All right. Can you speak about getting the data set on state plane coordinate system and how you implement GCPs? Also, when supplementing the data with conventional survey methods. How do you reproject data?
Is that for me or for you guys?
That's probably for all. It's the same answer from all of us.
Yeah.
Just reproject in the rock cloud.
Yeah, it's quite easy.
Pretty easy.
Once if you have known points, it's very easy to take your data set and make it match the known points in the rock cloud.
Yeah, so there's two things. Like in the cloud, you can basically just define what state plane you want to be in. It'll reproject the data into that state plane. And then if you have GCPs, you can further, use those as checkpoints. But you can also real time move the data set, easting, northing, elevation, and just click, or you can use the instant align tool where you just select the point, GCP, and the whole data set will go shift right to it. And then if you're doing, you go ahead.
I will say the SLAM data is a little more tricky.
Oh yeah.
Yeah. Because you're not just clicking one point and moving a data set. You have to click it, spin it, tilt it in multiple directions to make it. Mm-hmm. You have to match multiple ground control points.
Because it's coming from basically 0 to your project.
Right.
Yeah. Exactly. Yeah. So that's so you can do that too, where you have 4 more known points, and you say those 4 known points and where they, and you click on the data set where they are, and then it'll rotate, twist, and it'll translate. But then you can fine tune it, go in there and actually fine tune the matching to your aerial data set too. And I agree. I've gone to this. We're going to build an automated feature that'll do it better than, because we have one, but now it's going to get better.
Always.
I want it to be idiot proof. But also a grid to ground conversion. So a scale factor, you can do that as well. So if you have a local scale factor that you need to put in there, it'll, in the Rock Cloud, you can just click the advanced tab when you reproject, and you can enter in that scale factor. So it'll reproject using that as well. Yep. Good. Any more? Great. Okay. Before choosing Rock, did it seem risky to go with this family company that's operating in the U.S.? Oh, sorry. Versus a tried and true company. Did it pay off?
I will say, before choosing Rock, I sent inquiries to multiple other companies, and ROCK Robotics was the only LiDAR company that I could speak with that spoke the language of surveyors. I had to convince myself, or I had to be convinced that LiDAR data taken from a drone was going to be accurate enough for us to put on our surveys. And you guys were the first company that was able to articulate that in such a way that I could understand. David Song that works for you guys.
Yeah. And so works here.
Right, and he was the one that kind of walked me through how we can trust LiDAR data and exactly why. And so he did a great job articulating that to me. He knew exactly what I was talking about when I told him that I need survey grade. There's a lot of talk about what's survey grade. So
totally.
A lot of the drone LiDAR industry talks about locating power lines and doing electrical stuff or just getting general contours, which is cool. But we need survey grade. We need stuff to be as tight as our GPS as if we were out there shooting it point to point. And
totally, and even in my past experience before starting Rock, I worked with a lot of these companies, and they didn't even know what state plane was. They didn't even really just even that level. They were producing an LAS, and that was what they did. They tried doing that as best they could, and so we kind of came at it from, hey, we actually need this thing to turn around and make money. So we got to answer all these questions. Well, anyways, thank you very much, Davey, for choosing Rock, and we appreciate that. And but also, thank you very much for coming on the show today. It was a great pleasure to meet and talk and share your experience of surveying workflows with the audience. I think everyone probably gained a lot of insight and information from this. And congratulations on doing SLAM and integrating it all into aerial SLAM and getting planimetrics. That's really cool to see. I'm looking forward to seeing more of that. And for all those watching, stay tuned because we have our next episode coming on January 31st. So mark the calendars, and we'll see you there. And we'll see you here next time here on the Drone Money Podcast.